Welcome to Physics with Mr. Brazil. Today we're going to take Newton's second law and determine the forces on a box sitting on a horizontal plane and determine its acceleration using those forces. Here we go. So Newton's second law is F for force, M for mass, A for acceleration. So F equals ma. That's Newton's second law. So if we have a box on a horizontal surface, there are some forces that are generated. Let's put an applied force going to the right. So we'll put an applied force going to the right. Some teachers call that F of x. We'll have an opposing force, the friction, so F sub F, gravity coming downward on the surface of the plane, so F sub g, which is equal to mg. So it also it's a mass times an acceleration. In this case, g being 9.80 meters per second squared. Some teachers say 10 meters per second squared. And then there is a vertical force due to the surface, the two surfaces rubbing against each other on top of each other, and that's F normal. Okay, that'll be the y component. If you're an AP student, you need to write your actual forces, not the component forces. So you'll write Fn, Fap, Fg, and the force of friction. So do not write any component forces, and that's a proper free body diagram right here below in the left corner. Now, there's an equation you must memorize, and that's for for friction force. Mu equals the force of friction divided by Fn. Well, that rearranged equation is force of friction is equal to mu times Fn. Well, we can determine Fn if we take the component vectors in the vertical. In other words, we take the net force in the y direction. So I use the sum of all forces. That's all this is stating. So Fn is in a positive direction upward. Fg is in a downward direction, but since the box is neither going through the surface nor flying off the surface, we have a net force of 0. And so in this case, Fn is equal to Fg. And since Fg equals to mg, we now can apply this to the force of friction. So remember, you must know what mu equals. So in this case, for our scenario, we'll have a mass equal to 5.0 kilograms. Let's make mu equal to 0.015. Let's apply this information. Oh, let's give an applied force too. So let's make Fap equal to 15 newtons. See how this all unfolds. So let's start with our horizontal component. So in this case, Fx is going to equal to minus F sub F, that's the friction force, plus the applied force, which is going to the right, and this is going to be equal to ma. So the system is accelerating. In this case, I'm going to say to the right, a force of ma. So now we can find also the acceleration. We can determine the friction force from the equation right here in the right-hand corner, and we can now determine the acceleration. So A equals the force of friction minus the applied force divided by its mass. Let's do another step here. We're going to have minus mu mg plus F applied divided by mass. So let's plug in our values and see what we're going to get. So minus 0.015 times 5.0 kilograms times 9.80 meters per second squared plus the 15 newtons. Let's divide that by 5.0 kilograms, and we end up with an acceleration of 2.9 meters per second squared. Now we have the acceleration for this box. We can also determine the friction force if we want. And this is just the beginning step. So this is actually part one of a four-part series. So where I will do inclined planes and velocities and distances. So follow along and enjoy doing physics. Thank you.